Hello, everybody. My name is Otavio Santana, and today we will talk about Jakarta EE meets NoSQL at a Cloud Age. The whole point here is to talk more about what's going on with Jakarta EE and how can I make possible to connect my Java application with NoSQL database. Yes, for sure, and the Cloud Age. By the way, if you have any question, please let me know. Okay, I'm glad to be here to help you. We're gonna have a live code session because I love interaction. By the way, if you're here, please tell me where you're from. That's a nice opportunity to ice break. My name is Otavio Santana. My Twitter handle is Otavio Java, and I work in at Platform SH. Platform SH is a cloud company who has Canada. That's nice. Who has a goal to make easy the integration between uh, an application with cloud. I'm Java champion, the executive JSP executive member, Apache committer, Eclipse committer, Eclipse product leader, and on my free time, I usually write books and blogs about technology mostly. Okay, my presentation gonna be how NoSQL connects to a Java application in the cloud age. Please let me introduce to you NoSQL database. The NoSQL database has the exactly same goal that a SQL technology does, right? Therefore, it's a database. It's create something in the data, it's create some data, retrieve some data, update some data, and finally delete some data. It had exactly some goal to store information, usually from your application. If you think about architecture, you can think like the application is the brain of the architecture, and the data is like your heart, right? So you need that information that's vital to mostly of the whole application. And NoSQL database have different types different of SQL database because if you think about SQL relational database, you have MySQL, we have PostgreSQL, we have Oracle SQL, and basically all of those is the same type, some kind. You can do almost everything, and you have a standard language. And NoSQL database, that's not totally true. Therefore, we have different types of NoSQL database. Let's start with the first one. The first one is key value database. If you're a Java developer, you can think about the map structure where I have the key to find information and the value to retrieve that information. For example, here I have Apollo who has the key, and I'm gonna return the sun information. Aries, the war information. Aphrodite, the key, we're gonna return the love and beauty information. Key value database, we have a couple of implementations. Again, the most famous ones are Redis and Hazelcast in React. Again, if you're a Java developer, when you talk about key value, think about map. Key return the value. Let's move on to the second type, column family. Again, we have a couple of implementations. We have 8base, we have Scala, we have Cassandra, SimDB, Cloud Data, and DynamoDB. It's pretty similar to key value, where we have the key and usually we return information from the key. However, the structure of the information is a little bit different because instead of a huge blob that we have on key value, we split that information in small piece called column. This column has at least two parts. One, the column name, and the second is the column information. You might have a third information that column when you use a Cassandra, for example, that is the timestamp to define the latest information of the database. But basically, you have just two, the name and the information itself. For example, here, I have the key Apollo and the value as columns. I just have one column that is dirty and the information cell. Aphrodite is the key again. And right now, I have two columns. One is dirty with love and happiness information. Another one is color with pink, I hopeful, I'm no idea, information. And Aries, dirty war. One thing, if you are familiar with SQL database or relational database system, as you can see here, the information happened just in time. That is a little bit different from SQL database, right? Because usually when you work with SQL, we have the no information in the column. And usually in the column family, the column just will appear when you put any kind of information. Right now, we have one more type that is document. It looks like a document, XML document or XML document. The most famous implementations are MongoDB, Apache CodeDB, and Couchbase. It looks like XML, JSON document or XML document where I have documents. My document is a tuple where I have the name and the information itself. For example, here, name and Diana. I have the approach of sub-documents where I can put documents inside documents. So siblings, Apollo, brother. And the last one is graph database. The graph database, the relationship between vertex. Right now in the graph, I have an object to store relationship information. And that's amazing because right now I have the relationship directions. For example, here, I have three vertex, Apollo, Aries, and Kratos. You can think about tables. And instead of just have one-to-one relationship or one-to-many or many-to-many, I have direction relationship. For example, here, Kratos killed Apollo. But I'm not able to say Apollo killed Kratos because when Apollo goes to Kratos' direction, the relationship is gonna be was killed by. Then something happened in another side. Kratos killed Ares, and Ares was killed by Kratos. One direction, one relationship, one object, where I can put more information on that relationship. Graph database is really useful when you work with recommendation system or when you need to handle a system that has a lot of relationship, mostly man-to-man relationship. So GraphQL makes everything easy to you to handle this kind of situation. For example, recommendation. The most famous implementations are Neo4j, Infogrid, Sonys, and Hype GraphDB. Okay, right now I introduced to you NoSQL database. What does that mean? And let's move on to cloud. What is cloud? Okay, it is not a fancy definition, but basically cloud is somebody else hardware. Where if I am a software company, I don't want to spend a lot of time configuring everything. I don't want to pay somebody else inside my company to handle that. Because of that, I will pay some company to provide this kind of abstraction to me. Okay, so basically, briefly, cloud is somebody else's computer. For sure, it is much more than that, but yes. Because when you talk about cloud, you have knowledge, you have a lot of stuff. Cloud provides to us service. And the best analogy that I have to offer to you right now is the pizza as a service. Why? Because pizza and cloud are both, you can think as a service to both, right? So let's start. Let's begin. The first case is traditional on-premise or make at home. If you love to cook, basically is when you go to the grocery store, buy the whole ingredients, and then go to your home and prepare everything. You bring the cheese, the toppings, the tomato sauce, pizza, put in the microwave, prepare everything, take the drinks, and prepare the dining table. Basically, right here, that's so far the cheapest option. However, you need to have know-how, know-why, infrastructure, and if there is any kind of issue on middle of the process, that is absolutely on you. Okay? Hello, Haley. Nice to be here. I'm glad to you be here. Let's move on to the next one. Infrastructure as a service. Right now, I decreased the number of complexity, therefore I increased the abstraction. And in the pizza way, I will go to the marketplace or grocery store, buy the pizza, and I need to just put in the microwave, put some fire, prepare the dining table and the drinks, whatever you want, and ready. That is infrastructure as a service. Take it bake is probably more expensive. However, I have more abstraction on my side. I have less risk doing that this way. Okay, let's move on to the platform as a service. Less complexity and more abstraction mean usually more expensive. Right now on the pizza way, you can think about pizza delivery, where you do a call, request a pizza, and just put it on your table, and that is it. That is basically the platform as a service, where you usually just need to handle your business, your code business, right? So you need to put your code, and usually the platform as a service handle everything else you like a magic. So usually you don't need to handle the database, you don't need to handle the roles, the security, anything else. The last one, it is the highest abstraction possible, where you don't have any kind of risk because everything is on the provider. That is software as a service, or in the pizza language, dine out. You just need to go to the restaurant, order pizza, and that is it. There is no complexity around that. And that is something to the cloud perspective, where you have your Gmail or Twitter, whatever you want, and you don't need to handle about anything else. And that's the whole trade-off about cloud decision. If you go to traditional on-premise, that's fine if you want to, I don't mind. However, the whole complexity is on you. The whole know-how, you need to have the infrastructure, the whole risk, the whole everything. If you go to the highest abstraction, that means you're gonna have less risk as possible. However, you're probably gonna pay more because the cloud need to have that know-how that you're supposed to have. Okay, 1 second. But that is on you. You need to choose. You need to have the balance between them. Okay, I explained about NoSQL Cloud, and how about Cloud Native, because Cloud Native become a buzzword. So everybody mentioned Cloud Native everywhere. You it's probably that I'm feeling right now, you are tired to hear a lot of cloud native thing, right? Indeed, there is no a right definition about cloud native. If you go to different articles, probably each article provides to you a different approach or different definition about what cloud native is. Okay, let's take some. Uh, you have definition from Pivotal, we have definition from Cloud Computing Native Foundation, we have a couple of books. However, this presentation is not about cloud native, so I'm gonna skip and I go show my definition, at least what I have right now. Probably it might change with the time. But to me, cloud native is a set of good practice to optimize an application in the cloud through three approaches. The first one is containers. The second one is orchestration. That's the way how you gonna handle the containers. And the last one for sure is automation. Okay? Good practice to take advantage of application in the cloud age with containers, orchestration, and automation. Okay, that is the demo time. So right now I'm gonna show to you how it's possible to connect my Java application with NoSQL database. If you have any kind of question, please let me know. It's a pleasure to be here and talk about Java, right? Friday. It's a Friday night, at least to me, so it need to work. What I did right now, basically what I do have here is a simple Maven project where I have a couple of dependencies. So I'm using Weld, that is CDI 2.0. I have JSON bind from Eclipse Foundation. I have Eclipse microprofile configuration. I'm gonna show to you why later. And I have my specification on the Jakarta word. So if you have no idea, basically in the Jakarta word, we work with specification and implementations. And Jakarta EE is a huge platform to work with enterprise solution to Java. And under this umbrella, that is Jakarta NoSQL, it is one easy way to handle Java with NoSQL database. Okay? And today I'm going to introduce you Jakarta NoSQL. So Jakarta NoSQL has two dependencies. One, not two dependencies, but two layers. Sorry. One layer is my mapping layer, where you can think about APA, and in a layer below is the communication layer, where you can think about DDBC, right? Each layer has one API to a specific NoSQL database. Therefore, I have one API, one mapping layer, in one communication layer to key value, one mapping layer, your communication layer to document, and so on. Where to the mapping, I have my Artemis implementation. Into my communication, again, you're gonna think about DDBC, where my communication implementation will be a NoSQL provider. On this case here, I have one communication layer that is MongoDB, and one communication layer that is Redis. Okay, and this is the whole everything. I have Eclipse microprofile configuration, where you can see here I have a couple of configuration. Don't worry, I won't go through this configuration right now, but the whole point here is I can override the whole configuration. This information here is just a local application, right? And you can override the whole configuration of production. Therefore, That is amazing to you because you as a developer don't need to know the credential on production. And that's safe to you, and that even better to your company. Okay, let's move on. So I have my app application here, and let's connect my Java application. The first thing that I'm gonna do is to create my entity. Usually I create a God entity, but this time let's use a different one. So let's use, I don't know, let me see, maybe car. What do you think, guys? Car, maybe movie, like, because that's Friday, right? So no, let's use book. Okay, I will create book entity. I will provide an ID. This one gonna be a long ID, don't worry. This book will have a title, and usually this book has an author. And the last one, you be the categories. Okay, in the Java world, that's usually need to do, right? So I created my entity, and the next time is I need to think how can I map this entity to use NoSQL database. Jakarta NoSQL is a rotation-driven way. Therefore, I just need to put a notation to map my entity to go to NoSQL database. I usually define the book as an entity, so let's use entity annotation. This one another ID, let's use ID. Oops, no eject, but ID. And anything else as a column. So column, column, and column. Right now, I finally have my notes, my entity annotation. Let's create an constructor, an empty one, and let's have one second one with the whole everything. Let's put a toString here. And if you want to, you have the option to replace this with a builder. So in this case here, I'm using IntelliJ. And I usually have this kind of option. So builder, replace constructor with builder. So I'm gonna create my book builder. I usually use with as prefix, but you can set whatever you want. So on this case here, I finally have my book. So let's create my, and I will create my book effective Java. I will use book builder. What the author is Josh. I don't remember the. I guess that's the right way, but that's not the goal. The title is Java effective. And the category, as you see, right now I'm using Java 11, so I can put Java Dev Good Practice. And let's build. As you can see right now, yeah, it looks like a JPA annotation. I have my book entity. Oh yeah, I forget the ID. So let's put ID 1. If you want to make it even better, what you can do is create an static method. Builder, new book builder. And then you can do something like this. So book builder, and that is it. So you are creating a book. Okay, so the ID, everything here. My next step is, once I have my entity, is to storage this entity on the database. Jakarta NoSQL needs CDI. So let's create first the CDI container. If you are not familiar with CDI, in the version 2.0, it's possible to use Java SE. So CDI container, SE container, container, SE container initializer. And because it was created in the Java 8, you can use one feature from Java 7, that is try with resource. What does happen here? Basically, oops, we will create a container. When this code, within the code, the container will close automatically. What does that mean? If you have any kind of resource, the CDI might send an event to close this kind of resource. Resource, you can think about any kind of connection, whatever you want. Okay? I always will start with key value document type. Jakarta NoSQL has, as I mentioned before, two layers, communication and map layer. I'm gonna use more the map layer because it's probably that you're gonna use. And on the map layer, we have basically two ways to use the map layer. The first one is use the template that I'm gonna show to you, and then repository. If you are familiar with Spring, that is the exact same thing that Spring Data has. So let's start with templates. In Jakarta NoSQL, we have nomenclature, and each NoSQL database type has your home template. Therefore, if you want to work with a key value template, you're gonna use key value template. If you want to work with document template, you're gonna use document template, and so on. Also, want to work with key value, let's use key value template. Container, select, key value template, class, get. Right now I have my template and I have some methods. I'm gonna put my effective data here, effective Java here. Okay, and then I'm gonna return. So template, get, where I have my ID and my book here. This API is created on the Java 8. Therefore, you can use optional to return some gets, as you can see here. And one good point here is with just a couple annotation, you can integrate with a key value database. And remember, if you want to replace Redis to another one, just use React key, whatever you want here on the communication layer. Okay, right now overwrite it. Let's execute this. Before I forget it, I have my Docker Compose here to demonstrate my NoSQL database. I have my service where I have key value with the image Redis and document with MongoDB. So I put Docker down, Docker Compose up, and then I will start both Redis and MongoDB. Let's execute right now. It will run. Let's see what's going on. Oops, something goes wrong. Let's check. Oh yeah. On the scale here, as you can see, I forget to put the modifiers. And he will complain with me because my constructor is not public. So I need to make it public and execute again. The JSON binder was not able to create my instance. And as you can see here right now, it is able to. Sorry, today is a little bit hot in Brazil. And finally, what I did, I create empty, I put a retrieve, and then let's delete that information. So delete, and then find again. Let's copy paste here because we are developer, right? What else you like to do? And let's execute again. Yes, as you can see, I insert the book, then return the book, delete the book, and then when I try to find again, it's empty. Why we are using different API instead of you design something that the API does? Basically because the API was made to SQL database. In NoSQL, Jakarta NoSQL was created to NoSQL database. For example, usually NoSQL database does not provide transactions. And usually NoSQL database has time to live, where you can define the how long the information gonna hold. For example, here I'm gonna choose for 1 second. Duration of seconds. Instead of delete, what I'm gonna do? I'm gonna put to wait. Time unit, second, sleep 2 seconds. And I will execute again. Oh yeah, we need to put the throw here. So I put the magnet signature and let's execute again. I will execute, return, wait 2 seconds, and then return again. Once my time to leave is just 1 second, when they wait until 2 seconds, my information won't be there anymore. For sure, if you want to, you can put that 10 seconds, and I will return twice. Once, wait 2 seconds, and then twice. Why did it return? Because 10 seconds minus 2, it's left 8 seconds, okay? I guess it's left no anymore, but the whole idea is you can easily use the time to live to save your time on this kind of thing. Key value also have the query thing where you can return information from the query, right? So let's show to you as you can do. Templates, query. I can do a get one. You have the option to do a single query. Is there one question about IntelliJ? I'm not using plugin at all. So basically that's the default IntelliJ. I usually install a stock plugin, but basically what did I do here was I went to settings and increase the size to 27. This way you are able to see that easily. But anything else? And yes, I set the appearance to intelligent light because it's much easier to use see here as well. But basically, I don't use any kind of extensions in general. Okay, hopefully, if you have any more questions, please let me know. I will get the result here. So let's remove the duration. Let's remove the time waiting. And let's do the query here. So and let's execute again. This time using query by text. As you can see, yes, I can do that. Oh, Otavio, why not use select star from and blah, 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 blah. This looks like SQL database. Because that's key value. Remember, key value looks like a map where it just inform the key. And it will returns everything to you. So the SQL structure becomes useless to you because it doesn't matter each query you're gonna do. You basically need to return everything, and you just need to the query by the ID, the key. And if you want to, yes, you can use the prepare statement. So as you can see here, let's do the prepare save, where it's gonna return to me a prepare, and they're gonna bind. So ID, it's you have one. Okay, one more question. Okay. According to Wikipedia, sorry. No, Google. See, under the question about the database storage. Basically, it's on my Docker image. When I extract, the information will be there. Okay, so it's everything in my Docker image. So if I destroy my ID, as you can see here, and open again, it won't change anything because I can see that it's outside my ID. That's from the Docker container. To make easier, I create container with Docker Compose. But no, if the JVM restarts, you're not going to lose anything because you can think about relational database. So when you shut down your application, if you don't shut down the database, your information will be there. That's the exact same thing on the NoSQL database. Okay? As you can see, I will comment the put here and the query again. Okay, I close the ID, I queue the JVM, I want insert this guy again, and I'm gonna return something. So get a single result and execute. It will restart, it will execute, and as you can see, the information is still there. Held NoSQL, does NoSQL support time series database? No yet. Basically, right now we are working in the version 1.0, where you are working to release key value, document, and column family. Perhaps the graph database, but we are not sure yet. Why not yet? Because right now we have two kind of standards to graph database. We have Apache Tinkerpop. There is one standard from Apache Foundation, and Open Cipher. This one is a query from Neo4j. So basically, that's why we probably will release 3 versions. And remember, we release version every year. Therefore, if you won't release this version, on the version 1.0, you probably will release the version 2.0 or something like that. Okay, we will have the next year to release the time series. But thank you for the question. That's a good one. Okay, this time I explained to you about the key value. Let's move on to MongoDB, right? Let's go to let's go paste. And let's go to document database. It's almost exactly something. However, if I want to work with document, I want to use key value template. This time I will use document template. And for sure, I need to inject the document template as well. As you can see, I don't have the put anymore. Why? I'm gonna show to you. Let's comment here. I will search. I will find by ID. Okay, here, and I will execute. I insert, right? I don't have the put anymore. Let me try to run twice and see what's going on. I got an exception. Why? Because I'm not able to duplicate the key error. I'm not able to insert twice with the same ID. Instead, I should use update. One to insert, another one to update the information that I have. Okay, so that is the whole idea. Let me see. So basically, as you can see, on MongoDB in this case, they have validations. Instead, you can use insert and update. We use one more abstraction way, that is using repository. Okay, my time is almost over, so let's show to you. Book repository, where I will have a repository that extends repository, where I have the book and the long ID. Repository. I use a container to select. I use my book repository, not book build repository. Because I have 2 options, I have a key value document, I need to use qualifier. So in this case, I use database qualifier of document to define that as a document one, and then I will get. So what are we gonna do? Repository, save, effective Java, and repository find by ID. Why not? And let's run again. And as you can see, the repository will abstract you. If there is information in the database, I will update. If there is not, I will insert. Okay, that's the whole idea of book repository. So if you are familiar with Spring, that is pretty similar what Spring Data does and provides to you. So that is the whole concept about NoSQL database. When you go to now when you go to let me see, Cloud Native Solutions landscape, there is a huge word where you can brave to. There is a couple of options, as you can see. Right now we have over 1,000 options here. Why do I usually show that? First, because Cloud Native is much more than Kubernetes and Docker, right? We have a couple of more options here. And we have Kubernetes distribution that's through Kubernetes hosted, Kubernetes certifier, service provider, trainer, partnership, serverless, information, database coordination, and also a PaaS, platform as a service, container service, okay, where it's gonna abstract you to you go to directly to your code. We have a lot of solution that includes for sure the company that we're working, that is Platform SH. Platform SH is a company that has a goal to make easy to you take your application and move to the cloud. Okay, so I'm gonna show to you one application using microprofile and Helidon. You can take a look here. Don't worry. So let's show the link to you. I'm gonna show to you. Basically, that's a Maven project. I don't need to put anything else. As you can see here, I have my Helidon, my Artemis, my mapper layer, my communication, and that is it. So I don't need anything else. That's my application. What do I need left? Basically, if I think about the Java application with MongoDB, I need to think how to handle my MongoDB instance. Indeed, with Platform SH, you don't need to do that anymore. So I'm gonna show to you, but basically everything's included. If you want to take a look more details about Platform SH, in the link that I shared to you, there is the option deploy on Platform SH. So I will click here, KubeCon. I will take a new region, so Europe 3. I will continue. And basically, it's going to take from my repository in deploy application with MongoDB and Java container. And one important thing to say is the platform SH is going to handle the whole details like informations, the infrastructure configuration, the security environments, and anything else. You have the option to do the backup. If you want to, you with a single click button, you can do the backup and then restore your information. Okay, I create, and as you can see, as I mentioned to you, I have 3 files, one to represent the configuration, 2 routes, 2 application, and another one to my service that I need, on this case, MongoDB. On the platform stage, I have one branch, each branch is in one environment. On this sample here, I have my master, that is my master environment, okay? And what you're gonna do, basically, it's you take your application and deploy in the cloud. As you can see, I'm downloading the whole internet, so because it's Maven. right? Don't worry, I'm not gonna spend the whole time here. But basically, uh, the whole point here, at least the platform say, is to decrease the risk that you have to. So basically, we did two demos. One, the integration between Java SE and NoSQL database, and two, I share to you a link that has Java, microservice, NoSQL database, and you can use with cloud native way with platform message. Why does exist platform message? Because again, the pizza trade-off, right? So if you want to do everything at home, that's probably uh, nice to you, but you need to handle it with the complexity. You need to handle with the risk, because if something goes wrong, that's on you. And you need to have the know-how, you need to have the knowledge, you need to have everything on your hand. You need to handle the security, and today cloud is complex. And the whole goal of platform message is make it easy to you take your application to cloud next level. It's much more than a host. It's a polyglot multi-cloud pass, right? So if you want to run monolith, microservice, stateful, stateless, whatever you want, you can do that with platform message. Don't worry, I'm gonna show to you at the end the whole slide, the whole everything. It has the infrastructure as a code approach where you put what does your application need, push remotely, and that is it. As I mentioned before, you basically need to have three files: one to application, one to service, or another one to host. This one is application, where I have the name, I have the type and the version, so Java 11, the disk space, how to build, how to execute my application, and based on that, it will create my container, execute my container. When you talk about relationship, think about credentials. So basically what I'm doing here is I'm granting my application to have access to my PostgreSQL database. Okay. And as you can see here, I put service. Platform message provides several services such as MySQL, Postgres. I have the type, the provider in the version. Yes, if you want to, you can use the version that upgrade and push to the master or any kind of branch that you want to, and that is it. The platform message will upgrade to you. And the last one is the how. So each application do you want to make public? We provide the configuration reader. However, you don't need to do. Basically, you can override the whole connection to on your side. Okay, so that's the whole idea of platform message. We have the web console. It's gonna provide to you the whole everything that you want to. It's gonna run to you. It has CI/CD if you want to. So uh, we're gonna handle your code if you want, but you can integrate with GitHub, GitLab, and whatever you want. It has several runtimes, so PHP, Java, Node.js, Go, Python, and so on. And we have integration with MySQL, PostgreSQL, Kafka, Solr, and much more. And as infrastructure, we provide Amazon. Uh, we provide integration with Amazon, Google Cloud, Microsoft Azure, and so on. The whole idea is with platform message, we have infrastructure as a code where you can integrate with Git, with GitHub, GitLab, Bitbucket, and you can make your life easier to move on the cloud. We have a couple of clients. So right now we have over 1,000 clients. If you're a Java developer, we have a couple of integrations. So let's take a look. And that is it. So if you want to know more, there is this QR code here, but don't worry, I will show the link to you as well, where you have the sample code and the and everything. So if there are questions, please let me know. Will this presentation be recorded and available for download? I'm not sure. Probably it's gonna be on YouTube at the Eclipse Foundation. Oh yeah, you can watch this presentation with this link, so you can return to the beginning. And that is it. So if there is no question, thank you for your time. Hope that you enjoy.
Thank you, Otavio, and thank you everyone else who joined today. That was a lot of fun. Enjoy your weekend, everybody. Bye.
Bye.